Hey there, tech lovers. Welcome to Smart Coops, where we turn chicken care into a breeze. Imagine this. Your coop doors open automatically on a preset schedule. No more rushing out at dawn. Need to feed your flock? Just tap your phone and watch them feast. Easy peasy. But wait, there's more. You'll get instant alerts about potential predators, keeping your feathered friends safe and sound. Powered by the awesome Arduino UNO R4 Wi-Fi, this system is here to rescue you from those early mornings and constant checks. Let's dive in and build this smart coop together, step by step. We began by designing the coop in Fusion 360. This crucial step allowed us to create a detailed 3D model with precise measurements, giving us a clear vision of every component before construction. For the main structure, we chose 3/4-inch MDF for sturdy support, while using 1/2-inch MDF for the top section. This keeps everything well fitted and reduces weight. And here's the outline of the coop. Now we can move on to the interior design. The split door mechanism is the key mechanical feature inside the coop. We designed it using metal rods, a NEMA 17 stepper motor, and a GT2 timing belt with ball bearings. This clever mechanism operates by pushing one door while pulling the other whenever the motor moves, ensuring smooth and efficient movement. It's important to test everything before finalizing the design, so we decided to try out the mechanism using some scrap wood. For this project, we're using the Arduino UNO R4 Wi-Fi as our controller, which features a 32-bit microcontroller, the RA4M1 from Renesas, along with an ESP32 module for Wi-Fi and Bluetooth connectivity. We started by mounting the NEMA 17 motor to the L298 motor driver and integrating it with the Arduino. Using the stepper.h library, we ran some test code to make sure the motor operated smoothly. Next, we started 3D printing the necessary parts for the mechanism. Once the 3D print was done, we started connecting the parts required for the split door mechanism. After connecting everything to the wood, we used a 2mm acrylic sheet, cut at a laser shop for the door. Once we finished those connections and tested the code, it worked flawlessly. The door mechanism is now ready, so let's move on to the next part. Our smart chicken coop uses the Husky Lens, a smart AI vision sensor perfect for spotting predators. With its advanced machine learning capabilities, the Husky Lens can identify objects, faces, colors, and more, making it ideal for keeping an eye out for threats around the coop. Its built-in screen provides real-time feedback, showing exactly what it's detecting at any moment, making it user-friendly and effective. Training the Husky Lens is easy. Power it on and select the object recognition mode from its menu. Introduce it to common predators like raccoons, foxes, or stray dogs by pointing the Husky Lens at them and pressing the Learn button. To improve recognition accuracy, train from different angles and lighting conditions, ensuring it reliably identifies threats in various scenarios. Once trained, the Husky Lens connects to the Arduino UNO R4 Wi-Fi using the I2C protocol. For instant notifications, we've integrated Twilio, a cloud communications platform that provides APIs for messaging, voice, and video services. By using Twilio, we've set up the Coop to send email alerts directly to you whenever a predator is detected. This means you'll be notified right away, no matter where you are, adding an extra layer of security to your smart coop. Next up is the feeder mechanism. It's designed as a funnel-shaped box that includes an Archimedes screw. This screw will be connected to an SG90 servo motor for dispensing food. We opted for a continuous rotation servo to ensure a steady flow. To enhance food availability, we're using 2 feeders of the same size. Here are the 3D printed parts for the feeder mechanism. Let's attach the servo motor and see if it works. As you can see, it's functioning perfectly. We use a 12-volt, 3-ampere power supply as the main source. Since the Husky Lens and the SG90 servo motor operate at 5 volts, we incorporated a mini 360 buck converter to address this issue. To protect these sensitive electronic components from environmental factors like dust, moisture, and temperature fluctuations, we designed a dedicated enclosure within the coop. Now it's time to bring our smart coop to life. First, we began by cutting the wood to the required dimensions. We carefully measured each piece to ensure precision, as accurate cuts are essential for a solid and reliable structure. Once all the wood was cut, we moved on to the assembly phase. Using screws, we meticulously joined each piece together, making sure everything was aligned properly. This step is crucial, as a sturdy assembly will provide the support needed for the entire coop. With the structure taking shape, we turned our attention to finishing touches. We painted all the surfaces of the coop to protect the wood from the elements. This not only adds durability, but also enhances the overall appearance. We chose a color that complements the surroundings, giving it a stylish look. Now it's time to integrate the electronics. We carefully placed the various components we designed earlier, ensuring each part was securely connected. This includes the feeder mechanism, the split door system, and all the wiring necessary for the automation features. Finally, we added the top and front portions of the coop, sealing everything together. We made sure all connections were secure and that the structure was stable. And there you have it. Our smart coop is finally complete and ready for its new inhabitants. If you loved this video, don't forget to hit that like button and subscribe for more amazing videos. Got questions or ideas? Drop them in the comments below. We'd love to hear from you. Thanks for watching, and we'll catch you in the next video. Stay tuned.